we can't have negative answers here. So the only solution is x equals 7. In order to simplify the expression in number 12, I need to rationalize my denominator, which is the cube root of 16. And I need to multiply this by whatever this denominator, by whatever it's going to take to make it a perfect cube. Now I know the cube root of 16 is the cube root of 4 times 4. And if I multiply it by the cube root of 4 again, that's going to give me a perfect cube in my denominator, because I'll have the cube root of 4 times 4 times 4, which is 4. So here we go. I'm going to multiply top and bottom by cube root of 4. In the numerator, it's going to give me the cube root of 4 times 2, which is 8, plus, 6 cube root of 4 over the cube root of 64. And now simplifying, no, the cube root of 8 is 2, plus 6 cube root of 4. Sorry about that. And the cube root of 64 is 4. Let me just clean that up just a little bit. There we go. Now, what I can do is I'm going to reduce everything by a factor of 2. So this becomes 1, this becomes 3, this becomes 2. And so my final simplified answer would be 1 plus 3 times the cube root of 4 over 2. Okay, so in order to simplify our expression in number 13, I got to simplify each of these radicals. So I'm going to just break them down into their factors, looking for perfect square factors. 150 is 25 times 6. This is subtraction, sorry. 48 is 16 times 3, and 54 is 9 times 6. So now I'm going to take the square root of each of these perfect squares, and that'll give me 1/5 times 5, radical 6, minus 4 times 4, radical 3, plus 2 times 3, radical 6. Let's just clean that up a little. 5 times 1/5 is 1, so I've got radical 6 minus 16 radical 3 plus 6 radical 6. And now just combining my like terms, 6 radical 6 plus radical 6 is going to give me 7 radical 6 minus 16 radical 3. That's my simplified answer. Okay, number 14, I've got 3 expressions that need to be simplified. Let's take a look at each one. The first one, we're going to have to rationalize that denominator. So 12 over radical 2, we're going to multiply that by radical 2 over radical 2. The second expression, we're just going to need to get some perfect squares out from under that radical sign. I'm going to break 32 into 16 times 2. And then this last one, we just have to square it. So this is going to be 2 radical 3 times 2 radical 3. So let's see what we've got. We're going to get, in the first case, we're going to have 12 radical 2 over 2. In our second expression, I'm going to take the square root of 16. So that's going to be 4 radical 2. And in this last expression, I'm going to have 2 times 2, which is 4. Times radical 3 times radical 3, which is 3. So let's simplify a little more. 12 over 2 is 6, so I'm going to get 6 radical 2 plus 4 radical 2 minus 4 times 3, which is 12. And then I'm just going to combine these little puppies. I'm going to get 10 radical 2 minus 12. And there is our simplified answer. If you wanted to factor out a 2, you can do that, and then your answer would be 2 times 5 radical 2 minus 6. Either answer is correct. So for number 15, we've got some expressions with rational exponents, and we need to express them in radical form. Remember that the denominator is the root, the nth root, and the numerator is the power. So a to the 6/5 is really the same thing as the 5th root of a to the 6th. Now here we've got 5x to the negative 1/2 power. That negative sign means that this expression is really in the denominator. So we've got 1 over 5x to the 1/2 power, which is equal to 1 over radical 5x. We'd like to rationalize that denominator, so we're going to multiply it by radical 5x over radical 5x. And so our simplified answer would be radical 5x over 5x. Now let's take a look at the next one, 10n to the 3/2. So that's going to be the same as the square root of 10n cubed. I could also write that as the square root of 10n cubed. These two expressions are equivalent. Last one, or not the second to last one, I have a plus b to the 3/4, which means I'm going to have 1 over a plus b to the 3/4, which is going to be 1 over the 4th root of a plus b cubed. Now I want to rationalize this. I've already got 3 factors of a plus b. So all I have to multiply it by is the 4th root of one more factor of a plus b. 4th root of a plus b. Sorry, I'm out of room. And so what that's going to give me is, in my numerator, the 4th root of a plus b, and now I've got a plus b to the 4th power under that fourth root sign, which is just a plus b. So this would be my final answer. Let's take a look at the last one for number 15. We've got 2a squared to the negative 5/2 power. So we have a bunch of things to do here. First thing we've got to do is put this in a denominator. So we've got 1 over 2a squared to the 5/2. Now that's going to give me, here we go, 1 over the square root of 2a squared, that whole thing to the 5th power. What a mess. Let's take the square root of a squared. So we're going to have 1 over a radical 2 to the 5th power. So that's going to give me 1 over a to the 5th times radical 2 to the 5th. Okay, here's number 16. We've got a rational exponent equation, 2x plus 5 to the 3/2 power equals 125. So what we have to do here is raise each side to the reciprocal of the exponent. So I've got 2x plus 5 to the 3/2. I'm raising that to the 2/3 power. So this becomes 1, and I've just got 2x plus 5 on the left side of my equal sign. 125 to the 2/3 power is the same thing as saying the cube root of 125 squared, because this is the same as saying 125 to the 1/3 power squared. Okay, we can break our exponent apart like that to help us solve it. Well, the cube root of 125 is 5, and 5 squared is 25. And now I've got a pretty simple equation to solve. 2x equals 20, so x equals 10. Let's just plug that back into our original equation. 2x plus 5 to the 3/2 equals 125. So if I plug in 10, I'm going to get 25 to the 3/2 equals 125. That's going to be the square root of 25 cubed equals 125, and 5 cubed equals 125. Well, that is indeed true. So x does equal 10. Here's another rational exponent equation for us to try out. I've got 5x minus 3 to the 2/3, so equals 9. So I'm going to raise both sides of this equation to the 3/2 power. On the left side now, I just have 5x minus 3. And on the right side, I'm just breaking this exponent apart, 9 to the 1/2 power cubed, which is the square root of 9 cubed. So I'm going to get 5x minus 3 equals 3 cubed, or 5x minus 3 equals 27. Well, that's pretty simple. I'm adding 3 to both sides. I'll get 5x equals 30 and x equals 6. Let's check it. 5x minus 3 to the 2/3 power equals 9. So that'll be 30 minus 3 to the 2/3 power equals 9. 27 to the 2/3 power equals 9. Or the cube root of 27 squared equals 9, which would be 3 squared equals 9, which is indeed true. Therefore, the solution to our equation is that x equals 6. For number 18, we've got to add two expressions, but one of them has a radical in the denominator, so what I'm going to do is I'm going to rationalize this denominator first by multiplying the top and bottom of this expression by radical 2x over radical 2x. That's going to give me 6x radical 2x over the square root of 2x times the square root of 2x is just 2x. Whoops, sorry. Plus square root of 32x over 2. Well, if I look over at my first expression, I've got 6x over 2x, which simplifies to 3. So I've got 3 plus radical 2, I've got 3 radical 2x plus the square root of 32x over 2. But I can simplify this a little bit too, right? Because this is going to be the square root of 16 times 2 times x over 2. So let's continue to work on that. 3 radical 2x plus, I'm going to take the square root of this, I'm going to get 4 radical 2x over 2. Well, 4 over 2, as we all know, is 2. So what I'm left with is 3 radical 2x plus 2 radical 2x equals 5 radical 2x. Let me just fix that up a little. 5 radical 2x. Okay? So I'm just going to rewrite that answer one more time for you. Not messy. 5 radical 2x. If you have any questions about these, please feel free to shoot me a message. Thanks for being patient and waiting for the video.